we'll be starting with a new concept, and that is known as coordinate geometry. In coordinate geometry, we'll be working on a plane, a 2D plane. For a better understanding, let us go to our website. This is the 2D plane I'm talking about. A coordinate plane is just a paper with values, you can say. Over here you can see there are two lines, one vertical line over here and one horizontal line, and they're cutting through each other at this point where 0 is there. These are the two axes on the plane. The straight line is the y-axis and this horizontal line is the x-axis, just like in the graphs. Normally you don't see negative values on a graph paper, but over here we have negative values too. On the top it's y, on the right side it's x, on the bottom it's known as y dash, and on this side it's x dash. Y is positive, y dash is negative, x is positive, x dash is negative. X is the horizontal axis, y is the vertical axis. Let us go back to the whiteboard and draw this out. I'm sorry. Again. So we have values like 1, 2, 3, 4, 5. We have over here -1, -2, -3, -4, -5, and so on. Over here will be 1, 2, 3, 4, 5. This side it's -1, -2, -3, -4, -5. This top one is called y, this is x, this is y dash, it's represented like this, and this is x dash. X dash is negative, sorry, x dash is negative, y is positive, x is positive, and y dash is negative. We can also say y is north, x is east, y dash is south, and x dash is west. Coordinate system is used to put the world on a 2D plane and use it to calculate various pieces of information using it. On this plane, they put in all the information they need, and these units they use it to measure various things. Coordinate geometry has various applications in real life. It is used in air traffic, GPS, map projections, and in assigning latitude and longitude. Coordinate geometry helps in finding specific locations using latitude and longitude. A coordinate plane on its own is of no use. We use the coordinate plane for representing something. This is of no use. We use this to represent some data, put some data into this to make sense out of it. Now, let me give you an example. Suppose we have a point over here. Let's just say all of these are meters. 1 meter, 2 meter, 3 meter, 4 meter, 1, 2, 3, 4. You are right over here. And then you decide to walk 1 meter straight, 2 meters straight. There'll be a segment here. You walk 2 meters straight, and then you have some jetpack or something and you start flying. You fly for 2 meters, 2 meter upwards. You did this. This is your initial position and that is your final position, right? Initial position. Okay, no. Initial position, and this is our final position, right? This is called our walk, and this is our rise. What if the next time you want to reach from this starting position to this final position without having to go through this distance? What if you just want to directly go from here to there? You can do that. So let us just say this is a direct path between your final position and your initial position. You're directly going into the walking and then flying. Planes use this too. How do planes exactly land on the runway on a specific part? They apply these concepts along with the concept called trigonometry to find out the distance and the angle they need to drop at. Angle they need to drop at from how much distance from a specific place. And they use this to coordinate system to also navigate through, like, and on the radar system they have other planes which are nearby on the system which they can use to look around, calculate things. Other details are given to them. So we over here, what do you think this is? Sorry, no. So let us just look at this. All lines have something called a slope. What do you think of a slope? Probably you're gonna say like a steep mountain or like slanted surface. That's right. Not for the complete part, but yes. Slope is the amount of steepness. Slope is the amount of steepness. Now, why do we need that? I told you about the planes, right? So if you know the amount of steepness, with that you can use something called trigonometry to find the angle a plane needs to rise at or to drop at to reach a specific altitude at a specific time at a specific speed and cover a specific amount of distance. Slope can be used to derive other values and find other things. And in a coordinate plane, we should know how to understand different dots or points over here. Suppose you just have a point over here. What will you call this point? I mean, it has the name D over here, but what are its coordinates? The coordinates of D are 5, comma 1. Why is it 5, comma 1? I told you there is an x axis and there is a y axis. You have to give the value of its placement on the x-axis first and then its placement on the y-axis. If you look at the x-axis, it's at 5 exactly. If you draw a line from here to land at 5, and then if you look at the y-axis, if you draw a line from here to here, you would see that it would come to 1. So 5 comma 1 is your coordinate. Let's find the coordinate of these points. This would be 1 comma 1. This would be 3 comma 3. And the coordinate of this point is 3 comma 1. This is how we find, or we find the coordinates of a specific point on a graph. We first get its x value, and then we put the y value after it, after a comma. Now, let us reload this, right? Suppose you have a point over here, and then you have a point over here. Here also you can see this is how they're doing it. First you have the x value and then the other y value. That's how you represent it. I'm going to connect these 2 points like this. Why don't we try and find the slope of this line? It's fairly simple. Coordinate geometry. You just need to know a lot of formulas and know how this coordinate system works. If you understand how this coordinate system works, and if you know the formulas, you know everything basically. The slope formula is y2, I'm sorry, y2 minus y1 divided by x2 minus x1. That is the slope formula. What is x2, y1, y2, x2? Before finding that out, let's start finding the coordinates 3 comma 3 and 1 comma 1. Now this is x value, this is y value, and we have another x value, another y value. So we have two x values, two x's and two y's. So we need to assign one of them to be ones and one of them to be twos. By that I mean, if you're gonna say this is x1, then this is y1. It's the for your first coordinates, it's your x part and this is your y part. And for this is your second coordinate, this is your x part x2 and this is your y part y2. This will work even if you put assign this as x2, this as y2 and this is x1 and this is y1. But you can't mix and match. You can't say this is x1 and this will be y2. That's going to give you wrong answer. Because one set of coordinates, if one is x1, the other one is also x1. If one is x2, the other one is all. If one is x1, the other one is y1. If one is x2, the other one is y2. So let us find the slope of this. Now we said this is going to be our y2. So 3 minus 1, done. What is our x2? 3. 3 minus 1 again. So 3 minus 1, 2. 3 minus 1, 2. 2 divided by 2 would give us 1. The slope of this line, or we sometimes call it the gradient, is 1. You might say, wait, it doesn't make any sense. It doesn't have any units. Yes, it doesn't. In real life, there would be some units. Like I told you, this would be 1 meter, 2 meter, 3 meter, 4 meter, 5 meter. But over here, we're just looking at this simple plane. So we're now going to mention units. But you would need units in the real life. Without units, no values would make sense. Now, this is fairly simple. That's all there is to calculating slope. It's not that difficult. Now, let us get to distance. If I tell you, suppose that is this point over here, this point over here. If I ask you to give me the distance between these 2 points, what would you say? Let us say all of these are meters. 1, 1, 1, 1. 6 to 7, 1, 5 to 6, 1. Like that. How many meters is this? You would just go say this is 1 meter, this is 2 meters, this is 3 meters, this is 4 meters, and this is 4 meters. That's what you're gonna say, right? That's right. Let us look at the same thing with this perspective of coordinate geometry. When you looked at 4, what are the values you looked at? You only looked at the x-axis. You didn't look at the y-axis. Because only the x values are changing. Throughout, both C and D lie on the y coordinate 1. So, since that's not changing, we don't care about it. We are looking at only what's changing. But what if it's like this? You can't go and say this is 1, this is 2 over here, because that's not true. We will have to find the distance between these 2 points using a formula, and that is the distance formula. Let's go back to the whiteboard, and I'm gonna put a question over here. Let me give you the distance formula. It is d equals square root x2 minus x1 squared plus y2 minus y1 squared. This is your formula for distance. And this is fairly simple. We looked at what is x2, x1 previously in the slope. We decided to do the same over here. Now, why don't we try and find the distance between park and the bank? First step, find your coordinates. f4, 2. This is 2, 3. First your x coordinate and then your y coordinate. Done? Simple? Yes. So, now let's start substituting the values in. But we also need to assign x1 and x1 values and 2 values. So this set of coordinates is 1, this set of coordinates is 2. Let's say this is x1, this is y1, this is x2, this is y2. Considering this, 4 minus 2 squared, no matter how simple it is, it's always better to substitute in your values. Even if you get one step wrong, you would get correct mark, you'd get some marks for your right steps. y2 minus y1, that's your 2 minus 3 squared. That's gonna give you 2 squared plus minus 1 squared. That's your d. So d is 4 plus 1. So our d is square root 5. You don't have to go up past this. You can leave it at square root 5 and that's accepted. But if you're being asked to give your answer in actual numbers instead of square root, you can do that, but it's fine if you give it a square root 5. It's accepted. So the distance between the park and the bank is 5. Now, what if let's just say bank and the park again. What if you decide that you want to build a museum at the middle of these two. Could you tell me the coordinates? How do you find it? That's another thing we're gonna learn. It is called the midpoint formula because it's a middle point, right? So the midpoint formula would be, it's fairly simple and self-explanatory. X1 plus x2 divided by 2, comma y1 plus y2 divided by 2, right? Because if I'm getting the average of your both values, bank and park, middle is going to be museum. And let's just go with like our old assignment of x1, y1, x2, y2. Let us just start filling in the values. x1 is 2. So 2 plus x2 is 4. 2 plus 4 divided by 2, comma y1 is 3. 3 plus 2 divided by 2. 6 by 2, comma 5 by 2. So your coordinates are basically 3, comma 5 by 2. You can leave it at 5 by 2 or you can write 2.5. In a lot of cases, it's better to leave it in fraction because you tend to round off when the numbers go on. Let's continue. So you just try to round off. But to prevent that, you give it as a fraction form. Right? But over here, you can mention it. There is no harm in it. So those are your midpoint values. Middle point, your museum is gonna be built at 32.5. This is all for this video. In this video, we discuss what a coordinate plane is, what is a midpoint formula, distance formula, and slope formula. This will be a two-part series. Today we learn some of the basics of coordinate plane. In another video, the part 2, we are going to learn the rest. Thank you so much for watching. Subscribe to our channel, like the video, and comment down your thoughts about the video.